All right, so example 15 says, Arlene has two identical bags, each having the same chance of being chosen. Bag one contains 3 red balls and 2 green balls. Bag two contains 2 red and two green. So it's red and green. Arlene selects a bag at random and takes out a single ball. Draw a tree diagram to represent the possible outcomes in this experiment. Find the probability that the ball chosen is red. So the first thing Arlene selects is the bag. So she selects the bag. So you have bag one, and we're told that they're what? Each having the same chance. So there's a 50% chance of selecting bag one. And then there is bag two, and there's a 50% chance of selecting bag two. Now, after you select a bag, the next thing they're going to select is the ball. And you could either select a red ball or you could select a green ball. So you have red and you have green. In bag one, there are 3 red and 2 green. So the probability of getting a red is 3 out of 5, and the probability of getting a green is 2 out of 5. Bag two, you could either select a red ball or you could select a green ball. Now in bag two, each of them, in bag two, there's the same number of red and green balls. So the probability is 50% or a half. So this is the probability of bag one, red, bag one, green, bag two, red, and bag two, green. The probability here is equal to a half times 3 over 5. The probability here is a half times a half. Now, the question we're asked is to find the probability that the ball chosen is red. So you have 2 options for red. You have red here. You have bag one red, and you have bag two red. So the probability of red would be equal to a half times 3 over 5 plus a half times a half. So the probability of a red is the probability of bag one and red, or the probability of bag two and red. And for those mutually exclusive events, you must add the probabilities. So the probability here is 3 over 10 plus a quarter is 20. 2, 6, 5. The probability is 11 out of 20. So there's an 11 out of 20 chance of selecting that Arlene would select a red ball. All right, so example 16. In example 16, we're told that a manufacturer makes compact disc. A quality control officer is hired to check the quality of the disc produced. The officer tests a random sample of disc from a large batch and calculated the probability of a disc being defective to be 0.015, which is 15 over 1,000. The probability of it not being defective would be 0.985, essentially. We're to draw a tree diagram to represent the information. So how many discs did Deepak buys 3 discs? Calculate the probability that all 3 discs are defective. Calculate the probability that at least 2 of the discs are faulty. So let's draw our tree diagram. So disc 1. All right, and the option for disc 1 is that the disc could be what? Defective, or it could be good. So this one starting around here. It could be defective or it could be good. Disc 2. So disc 2, it could be so this 2 could be defective or it could be good. Could be defective or good. Now for the third disc, disc 3, defective or good. Defective or good. Defective or good. Defective or good. All right. So this is my tree diagram. This is D, D, D. This is D, D, G. This is D, G, D. This is D, G, G. Then immediately you have what? G, D, D. You have G, D, G, 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 D, and G, G, G. Now, the first thing we're asked to do is we're asked to calculate, draw the diagram, which we have done. The probabilities you should put on them. This is 0.015, and this would be 0.985. So the probability now, calculate the probability that all three are defective. So the probability of D would actually be equal to 0.015 times 0.015 times 0.015, which is the same as saying 0.015 cubed. All right, so somebody could work that out. Don't think we need to work that out per se. Then C, we're asked to, so that's the answer for B. Now for C, we're asked to calculate the probability that at least 2 of the discs are defective. When someone says at least 2, at least is an inequality term, which means what? Greater than or equal to. So if I say at least 2 are defective, essentially what I'm saying is I want the probability that 2 would be defective or all 3 would be defective. All right, so the probability of 2 defective and 1 good. So let's identify the amount of times we have 2 defectives. We have 1, 2, 3. It's only 3 times, right? 3 times. So the probability of 2 defective and 1 good is equal to 3 times 0.015 square multiplied by 0.985. Any questions or comments about that? Any question about that? Question or comments? No? Remember, each of them would be 0.015 square. That is 2 defective. Multiplied by 1 good, which is 0.985. But there are 3 of them. And the shortcut for adding the same thing 3 times is to just what? Multiply by 3. Yeah, but we're not finished. We're not finished. So now the probability of at least 2 defective would be equal to 0.015 cube plus 3 times 0.015 square this is 0.015 cube plus 3 times 0.015 square times 0.985. That should give you the answer.